Hey guys, MathMeister here. I'm going to talk to you a little bit about shape. So when we talk about shape, we want to know literally what does the data look like? Like what shape does it form? So I'm going to start with a normal distribution. Normal distributions are pretty much the most basic type of data distribution that we could have. They are typically bell-shaped, or not typically, they are bell-shaped. So we have this nice bell happening here. They're also symmetrical. So I can be symmetrical throughout my mean/median. So we notice that nice symmetry happening here. Now with a normal distribution, it's nice to know that they are unimodal. They have the mean equal to the median. And they are symmetrical. And they are bell-shaped. That's our normal distribution. Next, I want to look at a uniform distribution. Uniform distributions happen when everything is the same. So data is the same. Now, with these, everything is going to be very typical. We still have symmetry happening, so it's still symmetrical. Once again, our mean is going to be equal to the median. So we have everything is the same height happening here, and we still see that symmetry happening in our box plot. In a right skewed graph. A right skewed graph means that there are data values that have pulled your graph to the right. So here, most of my data is on the left side of the graph, and then I have these few couple of values that are pulling it to the right. I can see that in my box plot when I have 75% of the data is between 1 and 5.5, and 25% of the data is between 5.5 and 9. So we have this spread that's happening here where most of the data is located on one side of the box plot. In our histogram, we can see that most of the data is once again on the left, and then we have a few values that are dragging it to the right. Now, in a right skewed graph, our mean is greater than the median. So we have a mean that is greater than the median. A left skewed graph is pretty much the exact opposite of that. In a left skewed graph, most of our data is on the right, and then we have a few data points that are dragging it to the left. In this one, our mean is less than the median. So the mean is less than the median. We see that we have 25% of the data between 1 and 4, and 75% of the data between 4 and 9. And again, in our histogram, we see that most of the data is located on the left, and then it's being dragged to the, oh, I'm sorry, I said that backwards. Most of the data is on the right, and it's being dragged to the left. And then the last one I want to talk about is a bimodal graph. Now, a bimodal graph does not have to look like this. It is possible that the modes could be in different locations. A bimodal graph means that it has two modes. Two things are occurring at the same time. Now, this particular graph that I've drawn is going to be symmetrical. So it's symmetrical through the mean and the median. With our dot plot, we see the modes happening here at 1 and 9. They both have more dots than anywhere else. In our histogram, we see the same thing. We see that the interval from 1 to 2 and 9 to 10 is the highest. Now, in the box plot, it's a little bit trickier to see where that's at, but it's all about that spread. So 25% of my data is between 1 and 2. And between 8 and 9, that's another 25%. Whereas 50% of my data is between 2 and 8. So since this is such a small interval, that lets us know that we have a lot of numbers somewhere within there. And even though it doesn't necessarily mean that it's bimodal, it's a pretty good hint